Hello guys, welcome to the qualitative analysis section of specimen being given for the WAEC 2003, and two specimen was given named sample C and D. Sample C is glucose while sample D is zinc oxide. So let's take a look to the possible question that might come from WAEC, and let's solve it together, though it has been worked on in the lab. So these are the results from the lab, and let's just look at it. The first one, let's start with sample C, which is the glucose. When you have sample C plus water, it dissolved to form a clear solution. So in French, we have sample C to be soluble organic compound, and the C1 here represents the sample plus solution. I mean, the question might tell you should divide sample C. You should divide it into two. So add Ferlin solution. After adding a Ferlin solution, and you eat. When you have Ferlin solution, actually Ferlin solution we have A and B. Your teacher will have mixed the two together to give you a light blue solution. That's Ferlin solution. So when you add it to that clear solution, you have, first of all, you have a formation of blue solution because of the color of the Ferlin solution. So when you eat it, the blue solution is going to change. So under the heat, we are going to have a brick red precipitate form. Please just notice this on that, a brick red precipitate form, and the inferential, that's a reducing sugar, especially test for OH. When you say reducing sugar, it has the presence of OH and CHO. That's the two functional group present in glucose. CHO is the aldehyde, and the OH represent the alkanol group. So let's go to the third one, to the another portion of sample C, which is you've added water. You have acidified potassium diisochromate solution. Is yellowed in color. So when you add it to the solution, you have orange solution is formed. So when you eat it, the solution, that the orange color, turns to green on it. So it turns to green. So that shows the colorization of potassium, acidified potassium diisochromate. That's with an it's normally that kind of changes happen when you mix potassium dichromate with alkanol. That's potassium dichromate is an oxidizing agent. So that shows the conformation of OH here at the inference. We have the conformation of OH at the inference here. So let's look at the next step. That's sample D, which is the zinc oxide. So when you look at the zinc oxide, the question might come that you should put sample D in test tube and you eat. When you heat sample D, we have yellow when hot and white when cold. That's yellow when hot and white when cold. And this is one of the property of zinc oxide. Zinc oxide is actually an amphoteric oxide. You know what amphoteric oxide means? It has basic and acidic property. When you heat zinc oxide, it changes color in a reversible manner. So that's why the inference here is zinc present. That is an oxide of zinc. That's a zinc salt, zinc oxide salt. So when they said, another question might come and say you should put sample D, which is the zinc oxide, mix it with water. When you mix sample D with water, it is insoluble in water, and that means the inference here is that is an insoluble salt. So zinc oxide is an insoluble salt in water. So the next one, they might ask you to dissolve it in acid, to mix it with acid, and they mix it with acid such as HCl. It's dissolved in acid to form a clear solution. dissolve in acid to form a clear solution. Number 7 here, we now said okay, sample D, that's in test 2, with HCl and sodium hydroxide they drop an excess. Don't forget that sample D will dissolve in acid to form a clear solution. So when you now add sodium hydroxide to it, definitely you're going to have a white gelatinous precipitate form. White gelatinous precipitate form, and the inference here is not only zinc compound, zinc ion that formed out with sodium hydroxide. We have zinc, we have aluminium, and we also have lead ion. So they are likely present because 3 of them, even magnesium ion, to form white precipitate with sodium hydroxide. So in excess, the white precipitate dissolve in excess sodium hydroxide. Though aluminium and lead also dissolve in excess sodium hydroxide, but because we've already known our salt to be zinc oxide, so you're putting zinc confirmed here. And please note, whatever you're supposed to write at the column in front of the excess, don't put it in drop, and don't mix the two together. They are separate because there is a separate reaction for drop and a separate reaction for excess. So let's go to the next one. The question might also say maybe sample D plus HCl and from ammonia in drop and in excess. Remember, when you put it in HCl, which is acid, it dissolves to form a clear solution. If you now put ammonia, we also have a white gelatinous precipitate form. And remember, there we have aluminium, we have zinc, and we have lead ion likely present. In ammonia in excess, the precipitate dissolve in excess ammonia. When precipitate dissolve in excess ammonia, is only limited to zinc ion. Aluminium, zinc, and lead ion does not. The precipitate does not dissolve in excess ammonia. Is only zinc. So that is why you are going to put zinc confirm. Thank you very much, and watch out for the volumetric analysis. Thank you very much.